Hi students, good morning to all of you. Today we are going to discuss about polarization topic belongs to chemical bonding unit. From this concept, frequently one person we are expecting for different competitive examinations. Let us start polarization. Ionic bond is formed between cation and anion. Cation is positive charge having smaller size, anion is larger size having negative charge, right? When these two ions are approaches, some extent of covalent character is developed. How? That is, we can understand by applying the concept of polarization, right? Here, you take a cation, a sodium ion, is smaller in size, and anion, that is Cn minus, larger in size. When these two approaches, what happened? The beginning, earlier, the electron cloud of anion is symmetrical. Symmetrical means it is equally distributed, right? When cation approaches, when cation approaches, cation is smaller in size. The nucleus of cation pulls the electron cloud of anion towards it. Nucleus of cation pulls the electron cloud of anion towards it, right? The nucleus of cation pulls the electron cloud of anion towards it. That electrons present in the valency cell electron cloud, right? That leads to distortion of electron cloud or deformation of electron cloud. That leads to distortion or deformation of anion, right? So because of that, what happened? The electron cloud of anion is elongated towards the cation. Electron cloud of anion is elongated towards the cation, right? So that results the electron cloud of anion elongated towards the cation. Electron cloud of anion elongated towards cation. Because of that, here a sort of partial negative charge is developed, and this side a sort of a partial positive charge is developed. So when electron cloud is get elongated towards the cation, some extent of sharing of electrons is take place between the two ions. Some extent of sharing of electrons is take place, right? So that between two ions, some extent of sharing of electrons occurs. Sharing of electrons takes place between two ions. This phenomenon is known as polarization. This phenomenon This phenomenon is known as polarization. Polarization. Got it? Is it clear concept? Right. Now we can define. I am giving definitions. In polarization, we have to use two terminology. One is polarizing power, other one is polarizability. What is polarizing power and polarizability? Okay, so take a screenshot, my dear students. I can erase it. I need some more space. Yeah. Can I erase it now? Fine. Polarizing power. The power of cation. Power means ability. The ability of a cation to attract or to distort the electron cloud of anion is known as polarizing power. Polarizing power. Polarizing power. So what is polarizing power? Right. The ability of a cation, to distort or to polarize the electron cloud of anion towards it is known as polarizing power. Right? It is a power, it is ability of a cation to distort the electron cloud of large sized anion towards it. Next, second one is polarizability. Students, polarizing power, it is related to cation. Polarizing power, it is related to cation. Okay, that is next one is polarizability. Polarizability, right? It is related to anion. What is polarizability? Is the tendency of anion to polarize by cation. The tendency of anion to polarize by cation. Okay, it is a tendency of anion. Students, polarizing power, it is related to cation. It is the ability of a cation. And polarizability, it is related to anion, that is, it is a victim, right? So whose electron cloud is get distorted is anion. That is called polarizability. Right. So from this concept, what type of questions appearing for different company examinations we will discuss. So concept is clear now. Right? Yeah. Now, first I will go trick how to answer the questions related to this one. That is, a polarizing power is directly proportional to covalent character. My dear students, if when this happening, some sort of extent of sharing of electrons take place, right? So that results covalent character is developed in any compound. Okay, so that's why. So polarizing power is more, covalent character is also more, directly proportional, and it is inversely proportional to solubility of a compound in water, and it is also inversely proportional to melting point of a compound, right? So keep these points in our mind. Next one, if polarizing power is more, okay, covalent character of a compound is also more, then acidic nature of a compound is also more, acidic nature of a compound is also more, then solubility in water, solubility in water is less, then ionic nature, ionic character of a compound is less. Next, melting point of a compound is also less. Melting point. Then thermal stability of a compound, not stability, that is thermal stability of a compound is also less. Next one, basic character. Basic nature of a compound is also less. Right? Basic nature of compound is also less. So how can you remember this one? From this previous year questions are there, I'll tell you. So how can you remember is, these three are higher, right? That is PCA. There is polarizing power is more, covalent character is more, acidic character is also more. Next, this one, these are less, right? That is SIM. That is not mobile SIM. That is SIM means solubility is less, ionic character is also less, and melting point of a compound is also less. So PCA and SIM, these are more and these are less. SIM is less, right? See, the questions that are appearing for previous year questions is here. They will ask which amount of following having high polarizing power. That is, they will give lithium chloride and cesium chloride. You know, lithium chloride polarizing power is more, covalent character is also more. Because of covalent character, it is not soluble in water. So solubility in water is very negligible. It is soluble in organic solvents. Right? Got it? So that is next one. Take it here, aluminium chloride, that is AlCl3, and magnesium chloride. Which one having highest melting point and which one having least melting point? This is also previous year question. Aluminium chloride here, in this case, the polarizing power is more, covalent character is more. So that's why if covalent character is more, then melting point of compound is less. So that's why AlCl3 is less melting point because of high polarizing power and more covalent character. Got it? Next one, you know, beryllium chloride and barium chloride, which is soluble in organic solvent. You know, beryllium chloride is a smaller size cation. Size of the cation is smaller, polarizing power is more, covalent character is also more. That's why beryllium halides are covalent in nature. That's why these are soluble in organic solvents because it is high polarizing power and covalent character is more. Got it, my dear students? So these type of questions are appearing, and test questions, a few I am giving to you, we just try to answer this. The next video I will give solutions to that. So for example, take here, there is beryllium chloride and barium sulfate. Okay. So which one having high polarizing power? Okay, next one. Another one is, if you take it here, there is aluminium chloride and aluminium nitrate. Aluminium nitrate you take it, Al+3 and N-3 aluminium nitrate. So of these, so here both are common. The cation is common. So that's why I just represent, you take it here, a calcium chloride, CaCl2. Which one having high covalent character and less melting point. Okay. At last, one more thing. To take it here, lithium fluoride, and then sodium chloride. Which one having high covalent character? Got it? Fine. Okay, my dear students, I think you enjoyed this video. So thanks for watching my video, and like it, subscribe it. Okay, fine.